Hello, MT1. Welcome to the continuation of our discussion for the pre-laboratory of Module 8. For this session, we will be discussing about the amines and amides, discussing their properties and also some of the reactions involving them. Let us start first by taking a look at our objectives for the experiments and the discussion for amines and amides. For this session, we are expected to describe some of the physical and chemical properties of amines and amides, identify some tests that can determine the presence of amines, and then differentiate amines from amides in relation to their functional group. So amines and amides both have the functional groups that are containing nitrogen. So as you can see here in amides, they have the double bond O. Amines, on the other hand, only has our nitrogen and hydrogen. So this is their primary differences. Amides have carbon, hydrogen, oxygen, and nitrogen, while amines, on the other hand, only have hydrogen, carbon, and nitrogen. Let's start first with a discussion of the physical properties of amines. First, let's have a review about the classifications of amides. So it depends on how many R groups are attached to our nitrogen. So amines are a derivative from ammonia. So if a nitrogen has no R groups attached to it, it's simply an ammonia. If a nitrogen has one R group attached to it, it's what we call a primary amine. If it has two R groups attached to it and then one hydrogen, that is what we call a secondary amine. And then if all of the bonds are bonded to an R group, that is what we call a tertiary amine. As mentioned a while ago, amine is a derivative of ammonia. So it has a similar odor, but it's not that strong in comparison to ammonia. So if we are to make it an ammonia, we simply change this R to H. Okay, so if you change this to H or hydrogen, this is now an ammonia. But replacing one hydrogen with an R group gives us an amine group. Okay, again, similar odor with ammonia, but it's not that strong, it's not that pungent. Low molecular weight amines causes foul odor. Okay, let's say, for example, a dimethylamine, which causes the odor of a raw fish. This dimethylamine is an example of a secondary amine. How did we know that it's a secondary amine? Taking a look at our nitrogen, it has two R groups bonded to it and one hydrogen, making it a secondary amine. Low molecular weight amines are also soluble in water and are considered as weak bases. Okay, they are soluble with water because of the presence of the hydrogen bonding between first the primary amines and water molecules. So we have here our primary amine bonded with one R, and then it can easily bond with our water molecule. Because of this ease of bonding, they are easily soluble in water. We have to take into consideration here, we're talking about low molecular weight amines. How about the reaction of amines with other compounds? Since amines are considered as bases, even if they are weak bases, they react with acid to form water-soluble ammonium salt, or what we all know as neutralization. So if you react an amine, which is a weak base, react it with an acid, it will produce an ammonium salt. We call it an alkyl ammonium salt if it has an R group in it. Let's now proceed with amides. Amides, if you still remember, are considered as a derivative of carboxylic acid. So amides are produced as a product between an amine and a carboxylic acid, an acyl halide or an acid anhydride. So if you combine a carboxylic acid with an amine, it will produce an amide and water. As you can see here, the difference of amide and an amine is that amide has a double bond O, which is from the parent carboxylic acid. So what happens here is that the OH group from our carboxylic acid or the hydroxyl group from our carboxylic acid breaks its bond, and then in the amine group, we break its hydrogen. So there is a substitution reaction that happens here. The amine group, okay, or the amino group replaces the hydroxyl group in our carboxylic acid to produce an amide. And then hydrogen and then the oxygen bonds with each other to form the byproduct, which is water. Hopefully you follow through with our discussion about the formation of amides. Let's now take a look at their properties. As we've said a while ago, amides are derivatives of carboxylic acids, wherein the OH group is replaced with an amino group. Another property of amides is that they have neutral pH, unlike with amines wherein they are weak bases, and unlike with its parent carboxylic acid, which is an acid, amides are neutral in pH. They are also slightly soluble in water, and then they do not form salt with acids because, as mentioned, they are only neutral in pH. Let's now take a look at the reactions involving amides. We have here the hydrolysis of amides. Similar with hydrolysis of esters, this is only addition of water involving some catalyst to speed up the reaction. So in hydrolysis of amides, it can occur with an acid or a base. If you added water in an amide and then catalyzed it with an acid or a base, it might have different products. We'll take a look at it later on. In the hydrolysis of amides, the carbonyl and nitrogen bond is broken, resulting in a free acid and a free amine. Take a look at this one. So upon adding water with amides, we are producing carboxylic acids and a free amine. So this is the amine that we're looking for, and then this is our carboxylic acid, which is COOH. Now, as mentioned a while ago, it can occur, or hydrolysis of amides can occur with either acids or bases. If you reacted it with an acid, what will happen is that it will convert the amine to an amine salt. Okay, so upon making a free acid and a free amine, it will further produce an amine salt. Okay? If you added base on it, it will convert the carboxylic acid to a carboxylic acid salt. Okay, it depends on which catalyst you use. Again, going back, if you added in amides, if you added water and catalyzed it with an acid, it will produce first a carboxylic acid and an amine salt because the amine will further be developed into an amine salt. If you reacted or if you catalyzed the amide with a base, it will convert the product carboxylic acid to our carboxylic acid salt, wherein your final product in the hydrolysis of amides will be carboxylic acid salt and a free amine. And hopefully you understand that there might be some additional changes based on the catalyst that you use. That is the end of our discussion for amines and amides. Here is the reference that I use in the discussion. If you have any questions regarding our discussion for the pre-lab, kindly email me at my AUF email, and you can also message me on my class. That's all for our pre-laboratory discussion for Module 8. Thank you and God bless.